Okay, good morning. Welcome to week 5. This week we're going to take a look at a couple of sort of miscellaneous things. They're not really very related to one another. First of all, this morning we're going to look at what are called regular expression pattern matching notations. These are very powerful and very compact notations for identifying patterns of text in text files. They're one of my favorite things of all time. We're also going to take a look at reading and writing formatted data from files. We've looked at reading just ordinary files and like the colon separated value file, the expenses file. Now we're going to take a look at some higher level tools that we can use for accessing comma separated value files or JSON files or various other kinds of formatted files. And then the last part of this will be some string handling methods that we'll take a look at on Thursday. Okay. So regular expressions are a sort of a mathematical style of notation for describing patterns of text. And these things were originally developed to describe human languages, particularly grammars. Computer scientists picked these up and started using regular expressions as a way of describing programming language syntax and correct structure. So Python has an extensive collection of regular expression characters similar to those that originated, well, they probably originated even before that, but I at least was first introduced to these things in the Unix operating system. There is a command in Unix and Linux called grep, which is the global regular expression print command that searches through a text file and displays for you all of the lines that contain a certain pattern. Okay, so Python's regular expression characters are very similar, although more extensive than what's available from grep and its other Unix/Linux relative called egrep, the extended grep. In a regular expression, most characters just match themselves. So in other words, the regular expression capital A matches a line that contains, or in the case of Python, matches a string that contains a capital A somewhere. And colon is not a regular expression special character, so if you search for a regular expression containing a colon, you're just matching the strings that contain a literal colon character. But the caret symbol, also called the circumflex, the up arrow, the hat, and various other things, I like to call it the caret because that's short. The caret symbol matches the beginning of a string. So if I search for a pattern caret capital H using a regular expression searching function in Python, that will display for me or match for me the lines that start with a capital H. Now, to illustrate each of these successive regular expression characters, we're going to take a look at what these things match in this silly poem, Lewis Carroll's How Doth the Little Crocodile. Yeah, this is from Alice in Wonderland. There's another poem I like to use from Through the Looking Glass, but whatever. This poem has the advantage of having some nice patterns that we can search for. It also has the advantages of being a little bit funny, so it's easy to remember, and short, so everything fits on the screen. Okay, so I have, and it should be posted on Canvas, and if it's not, I will certainly do that. I have a program called regexexamples.py that has within it this silly poem in the form of a list Okay, the square brackets create poem as a list of stir values, that is, string values. And when I run this regular expression search method, looking for the pattern of interest in some line of text, that's going to return none if there's no match. Otherwise, it will return a match. And for our purposes, all we care about is that it's not none. Okay, so if we do a regular expression search for a pattern in a line and we get none, that means there wasn't a match. Otherwise, there was a match. And so if there was a match, we're simply going to display the line containing the match. Now, in order to use this regular expression search method, I have to import the regular expression module. Okay? So we're importing the regular expression module, and let me run this program. I do have lots of other examples in this program, but they're all commented out, so nothing will happen from those. And let's see what lines in the poem begin with a capital H. All right. Okay, so in my silly poem, whoops. Turns out there are 3 lines that begin with a capital H. The title line starts with a capital H, and the first lines of each, what are the parts of a poem called? Stanzas. Thank you. So the first character of each of the stanzas, each of the individual stanzas, is also a capital H. So I got 3 matching lines from that search. So far, so good. Okay, so the next regular expression character we want to take a look at is the dollar symbol. The dollar symbol matches the end of a pattern, or the end of a string. And so if I search for caret dollar, well, let's see, the caret matches the beginning of a string, and the dollar matches the end of a string. And what characters are we allowing to exist in between the beginning of the string and the end of the string in this case? No characters. The beginning and the end have to be right next to each other in order for this pattern to match. So let's try that one. And I'm just going to move that up. Okay, let me... Hey! My Control X doesn't want to work. Something funny is going on here. Alright, I'll type it in manually. What the heck? So I'm going to say pattern gets caret dollar. And we'll run this. Okay, now, you know, a blank line doesn't have any characters in it, so you have to kind of squint and count here. But it turns out that there are 3 blank lines in this poem. There are the blank lines between the dashed line and the author's name, and then between the author's name and the first stanza, and then between the 2 stanzas. So we've got 3 blank lines. So far, so good. Now, one character that's a special character in regular expressions is the backslash. And the backslash would turn off the meaning of the very next regular expression character. What I mean by that is, if I wanted to do a search for a backslash, I'm sorry. If I wanted to do a search for a literal caret symbol in the poem, I can't search for caret like that because that means beginning of line. What I have to do instead is to put a backslash in front of the caret And, well, I guess I better have a string to compare against here. Okay, now there is no literal caret symbol in How Doth the Little Crocodile, so I'm going to get none returned. On the other hand, if I do a regular expression search for a literal caret symbol in the string, here are some carets, and that is how caret is spelled for this punctuation symbol. This time there is a caret. There are multiple carets, but there is at least one caret in the line, and so I get back something that's not none. Okay. In particular, what I get back is an indication of where the match is found. So the match is found at index sub 22, and it goes up to, but not including, index sub 23. Now, so I can use the backslash to turn off the special meaning of one of these regular expression characters, like the caret or the dollar or various other ones that we'll get to. But that sort of raises a question right away, which is, how do I search for a literal backslash? And the thing one might try would be to double up the backslashes to get a literal backslash. However, I get yelled at when I do that. And the reason is that, as I've indicated with this example, completely forgetting about regular expressions, if you're just dealing with strings, there are certain characters that you have to put a backslash in front of in order to get those characters treated as special characters. In other words, if I say S is, this is 2 lines with a horizontal tab in line 2, to represent a new line character, we know that within a string we have to say \n. But internally, that's actually just one character. It is the new line character. It is not stored in the string as a backslash followed by an n. It is stored as a new line character. Similarly, \t is not 2 characters. It's stored in memory as 1 character, which is the horizontal tab. All right. Now, if I print S, I see that this is, and here's where the new line occurs, and then here's where the horizontal tab occurs. So I see those new line and tab characters displayed in the output. And maybe I should use a shorter example to prove that they're not stored as multiple characters. Each of these is stored as a single character in the string. So the len of S2 here is just 2 characters, not 4. Everybody good with that? If I want to have a backslash in a string, because the backslash is also used to represent things like new line and tab and form feed and carriage return and lots of other special characters, I have to use a pair of backslashes. Okay, so the pair of backslashes within the string represents one single backslash. And this pair of backslashes in my source code is stored internally as a single character. I know this is really getting long. All right, now let's get back to regular expressions. So what this means is, if I want to do a regular expression search for a single backslash character in a string, well, this regular expression pattern is also stored in a string, and I have to type backslash backslash to represent one backslash, and backslash backslash again to represent another backslash, which is how in a regular expression you search for a single backslash. It's unpleasant, right? So if I search in S2, I will get a match. Okay, there is one backslash starting at location sub 21 and up to but not including location sub 22. Let me prove that. So if I ask for S2 sub 21, yes, that's the backslash character. It's one character. It's not really two backslash characters. It's like if I, in S, if I say, well, if I say S sub, let's see, so it would be 7, I believe, is where the new line character is. Okay, so S sub 7 is the new line character, although in source code it appears as a backslash n. Now, nobody wants to have to remember, when they search for a backslash, to have to type 4. So that's why we are putting an R in front of the pattern. That makes the string what's called a raw string, in which each individual backslash is treated as a literal character rather than an introduction to some other special character. So if I say S3 gets backslash n, then the length of S3 is one character. It's a single new line character, correct? But if I say S4 gets raw backslash n, now the length of S4 is 2 characters. If I print S3, I'm just going to get a blank line. Whereas if I print S4, I'm going to get a backslash character followed by an n character. I know this is horrible. But this is why we're sticking R's in front of all of our regular expression patterns, so that we don't have to double every backslash that we want to have be a single backslash in our regular expression. Okay, so we've looked now at caret, which stands for the beginning of the string, and we've looked at $, which stands for the end of the string. Next, we're going to take a look at square brackets, which means to match where is it? There it is. On slide 3. Okay. So the square brackets mean to match any one character within the list of characters specified between the brackets. And consequently, if I do this pattern here, square bracket A dash Z, now that's actually an example of a range, and it means I don't have to type capital A, capital B, capital C, capital D, capital E, all the way to capital Z in my square brackets. I can just say from A up to and including Z. And consequently, what we're looking for in this pattern is strings that begin with 2 space characters followed by a capital letter, immediately followed by a capital letter. Let's take a look at that. So these are lines that begin with space, space, and then square bracket A dash Z. Whoops, forgot my closing square bracket. And I could have said A, B, C, D, E, F, G, H, I, J, K, L, M, N, O, P, Q, R, S, T, U, V, W, X, Y, Z in brackets, but goodness, who wants to? Okay. All right, so we'll run this. And here are all the lines in the poem that begin with two spaces immediately followed by a capital letter. If we look at the actual poem, that's interesting. Why did I get 3 lines and not 4? How interesting. Maybe I have a bug in my program. I made some changes to my data file, which okay. Okay, I had made a modification to my poem by sticking a tab in front. Now that I have changed the tab back to 2 spaces, when I run my program, I will get those 4 lines out that consist of 2 spaces followed by a capital letter. Okay? Okay, so that's the square brackets. Next, we're going to look at the whoopsie. There we go. Next, we're going to take a look at the star character. Now, what the star character means in a regular expression is to match any sequence, including a sequence of 0 characters, of whatever the prior character is. So the star in regular expression notation never just is used by itself. It's always used following some character. And in our code, what we're going to look for is space star. Now, I accidentally highlighted the square bracket, which I didn't mean to. But this pattern, this third pattern here on slide 7 says, let's look for lines that begin with space star. Now, what space star means is no spaces, or 1 space, or 2 spaces, or 3, or 5, or 1,000, or 1,000,000 spaces. And immediately after that sequence of some arbitrary number of spaces, then we want to look for a capital letter. The point here is that the space is optional. There might be no space, or there might be some arbitrary number of spaces from that pattern space star. And so when I run this test, setting my pattern to raw, caret space star, and then A through Z, I will get all of the lines in the poem that begin with a capital letter, possibly indented, or possibly not. The indentation is optional. Okay, and so here are all of the lines in the file where the first character, other than a space, is a capital letter. Yes?
What's the difference between matching and greedily matching?
Okay, so star is said to be greedy in the sense that it will match as many characters as it possibly can until it hits a boundary that violates what it's trying to match. So when I say space star, and if I look at my poem, when I say space star, it's going to match as many spaces as, whoops, sorry, wrong line. It's going to match as many spaces as it can. Well, I guess I can't highlight on this. Okay, so in the PDF I can't highlight these spaces. But it's always going to match as many spaces as it possibly can until it hits a character that's either not a space or that satisfies whatever the pattern is to the right of the space star. Yes. So to the right of the space star, I have a capital letter. All right. So in the first line here, the greediness of the space star matches as many spaces as it possibly can, which in this case is no spaces, because then we hit a capital letter and we can't continue matching any further. However, that does satisfy the overall pattern. It satisfies looking for 0 or more spaces followed by a capital letter, so it's a match. The next line down here, we have 0 or more space characters, but then we have a dash, so that's not a match. The next line down has a whole bunch of spaces that the space star matches, but then we hit a little b, which is not a match for the capital letter. Does that help at all? Okay. Any other questions so far? Okay, so what we mean by greedy is that it will match as many characters as it possibly can until it hits a boundary at the end of what it's matching. Yeah.
So how do we specify A through Z and then the dash character too?
Ask me that again?
How would you specify a range and then add another character to that? So if you wanted to search for all A through Z and then also the dash character.
Oh, very excellent question. Okay. Let me finish talking about the star, and I'll come back to that if I may. I don't want to interrupt the flow such as it is here. Okay. All right. So that's one example of star. Here down here is another example of star. This time the star is being used together with dot. And what dot means, let's see, I've lost my highlighting somehow. Come on, there we go. All right, so what dot means is to match any single character. All right, so dot matches one character exactly, but it could be any character in the machine's character set. It could be a control character, it could be a new line, it could be a letter, a digit, a punctuation mark, whatever. And as a really simple example, okay, I've got poem here. If I say, let's see, what's the value of line? Okay, so line is the last one here. If I say regular expression search for G.E in this line, what I'm saying is, let's see if the pattern little g followed by exactly one character followed by E, whoops, obviously I meant N. Let's see if the character little g followed by one character followed by little n exists within the line, and it does at character sub 7. So here is a match for G dot N. Okay, little g followed by E followed by N is a match for G dot N. If I say search for, let's say space dot 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 I in line, now I'm saying, can I find in this line a space character followed by exactly 4 characters, I don't care what those 4 characters are, followed by an I. And yes, I get told there's a match starting at position sub 13, and here it is, space, SMIL matches the 4 dots, and then I matches the I. Okay, so dot matches any one character, regardless of what that character is. Consequently, if we look at dot star, remember star modifies the meaning of the character right in front of it. So dot is any one character. Dot star means 0 or more of any character. In other words, dot star together is like a wildcard that matches anything. So what I'm doing with this pattern is I'm looking in the poem for lines that contain a little a followed by anything, including no characters at all. Dot star is entitled to match no characters. Immediately followed by a little e, followed by any amount of characters, followed by a little I. In other words, lines from the poem that contain little a, little e, little I in order, but we don't care what's in between the little a and the little e, and we don't care what's between the little e and the little I. Okay? So let's see what we get for a match from that. All right, so I'm going to use my pattern. Looking for A followed by anything. Look for E followed by anything. And then I. Now, I don't care where the little A is. And I don't care where the little I is. I just care that between the little A and the little I, there has to be a little E. Let's see what we get. There we are. So apparently we've got two matches. Let's see if we can find the matches. So here is a little a, and here is a little e, and here is a little I. Now, notice that in between the a and the I, there are actually two little e's. We don't really care. All we require is that there be a little e, maybe there's more, and that there eventually be a little I. So we've got little a, little e, little I, in order with other characters in between. And then down here we have little a and little e. Now we've got another little a, but we don't really care. And then we've got I. So that line also has little a followed by little e followed by I. Make sense? Okay. Now I do want to come back and answer your question about how do I, using square brackets, if dash represents a range, how do I look for a dash? It's a good question. Well, there's some trickery here. Let me create a string, S, what am I up to? S5 gets all right, so there's my string S5. Happens to have a dash in it. And if I look for this pattern, when I'm manually typing patterns, I always forget the R, but I should be consistent. And if you're consistent and always use the R, then you don't have to worry about quadrupling your backslashes if you use backslashes. All right, so I'm going to look for a digit between 0 and 4, followed by a letter or a dash, followed by a space. Now, okay, so in square brackets, dash means range if dash is between two other characters. But if dash appears at the end of the square brackets, or if dash appeared at the beginning of the square brackets, then it just means dash. It means that dash is one of the choices. All right, so I can say A dash Z dash, and that means look for a capital letter or a dash. And we want to look in our S5 here. And yes, we got a match starting at position sub 3. So here is position sub 3 dash. Okay, so 4 dash space matches some digit between 0 and 4, followed by an uppercase letter or a dash, followed by a space. Now, the same is true. Another question is, okay, in square brackets, how do I look for a square bracket? So I'm not going to create an example of this, but it turns out that in square brackets, let's suppose that you want to look for either an open square bracket or a closed square bracket. Okay, so you're interested in matching either an opening square bracket character or a closing square bracket character. So you can't say this because that set of square brackets matches or ends at the first closing square bracket. And it says, look for an opening square bracket followed by a closing square bracket. And actually, technically, if I really wanted to do that, I would put a dash, a backslash in front of the square bracket there. So that doesn't work. What you do instead is like so. If you have your opening square bracket, if the very first character following the opening square bracket is a closed square bracket, then the regular expression notation understands, closing square bracket is one of the choices I'm looking for. And then if I have another opening square bracket before I hit my final closing square bracket, then opening square bracket must also be one of the choices that I'm looking for. So I know this looks a little odd, but what it means is look for one of the characters within this collection of characters, which might be either a closing square bracket or an opening square bracket. Okay? Other questions? Yes.
Why can't we just use a backslash for this?
Okay. Good question. And it doesn't work, but why doesn't it work? I should know why. It doesn't work. That's all I can say at the moment. Sorry. I'm sorry?
I got it to work.
Did you get it to work? Give me an example. So let me create S6 with some square bracket in it. Did you create an example or?
Or with the S5 string, I got this same match that you did with just a backslash dash Z instead of a dash Z dash. So you said this. You said R, and then your pattern was a backslash R 0 to 4,
0 to 4,
and then a backslash dash Z.
Okay. Now, what I believe that means is to look for a capital A or a dash or a capital Z. So it doesn't actually mean look for a capital letter or a dash. It means look for a capital A or a dash or a capital Z. Can you say, well, let's give it a try. Now, I'm also just going to throw out there that there are many generations of tools using regular expression notation, and they may not all be entirely consistent with each other. I learned this stuff back in the previous century, working on Unix and Linux systems. Okay. And it could be that Python's implementation of regular expressions is slightly different than what I'm familiar with. But let's see if I have, let's say S6. Let me try that again. S6 gets, quote, okay, so there's nothing inherently special about a square bracket character in a string. Now let me see if I can do a search for an opening square bracket in S6. All right, interesting. I got a warning here. It's not an error, it's a warning. And it told me, okay, I did find a match. But let me search for, okay, so here's S6. Let me say S6, regular expression search for the raw pattern, open square bracket, close square bracket, open square bracket, close square bracket in S6. And I don't believe I'm going to get any warning here, and I will get a match. Yes. So it was able to find either an opening square bracket or a closing square bracket within this string, and in fact what it found was the opening square bracket at position sub-0. Can I look for either an opening square bracket or a closing square bracket within my collection in a 6? It worked. So yes, so in Python, yes, you can use a backslash to turn off the special meaning of the opening square bracket or the closing square bracket. Cool. Okay, so I'm just going to leave it there. Good. Other questions?
Sorry, just wondering, could you go up a little bit and explain the regular expression where you had 0 to 4 and also a dash z dash? Or you did not write it well?
This one here?
Yeah.
That one?
Yeah.
Okay.
For the a dash z dash.
Okay. So a dash, so in square brackets, a dash between two characters means to search for any character within that range. So it means look for either a capital A or a capital B or a capital C, blah, 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 or a capital X or a capital Y or a capital Z. So any uppercase letter. And I should really be clear that we're talking about if your system's character set has capital A through capital Z in sequential ascending order, which ASCII machines do. So most computers that you're going to work with are going to have that. Now, following the capital A dash capital Z, I'm saying that just plain dash is also a character that will match, a character that we're willing to match. And in my test string, I'm looking for something between 0 and 4, followed by something that is either a capital letter or a dash, followed by one space character. And the only place where I have a match is 4 dash space. Did that help?
Yeah.
Onward ho? Okay. All right. So $sign we've talked about. Dollar matches the end of a string. $, therefore, matches lines that end with a little e. Let's see if we have any of those in our poem. So I'm going to say Pat is our $. little e. Oh, I got my caps lock on. Okay, so E is not a special character. E just matches E. And in this case, I'm saying I want to match a little e that occurs right at the end of the input. Okay, and I do have 3 lines in my poem where the last character on the line is a little e. Now, if I use 2 sets of square brackets side by side, what I'm saying is I'm interested in matching 2 characters where the first character is one of the characters in the first collection, in the first pair of square brackets, and the next character is one of the characters in the second set of square brackets. So in other words, if I'm looking for, in square brackets, little a, e, I, o, u, that means look for one of the lowercase English vowels. And then if I have that same square bracketed pattern again, it says, okay, now look for another lowercase English vowel. So I'm going to look for lines that have 2 lowercase vowels right next to each other. They're not necessarily the same vowel. They can be arbitrary lowercase vowels. So let's try that one next. So pattern is, okay, square brackets means one of, A, E, I, O, or U, immediately followed by one of A, E, I, O, or U. I forgot my R. Now, I don't have any backslashes in here, so I can get away without the R, but you know, it's always wise to be consistent. Use the R even if you don't need it. And there we go. So where do we have matches? Okay, so here we have tail, which is 2 lowercase vowels next to each other. Pour, cheer. Now, in the case of cheer, they happen to be the same vowel, but that doesn't really matter. And neatly. All right, so each of these lines does contain a lowercase vowel immediately followed by another lowercase vowel somewhere within the string, somewhere within the line. All right, next up, we're going to take another look at the caret symbol, but this time we're using the caret inside the square brackets. Now, this is unfair, but it's not my fault. Somebody came up with the idea that, oh, if I use a caret symbol inside of square brackets, that's going to invert the collection that I'm looking for. So this notation right here, where I'm saying square bracket, caret little t, close bracket, means I'm looking for one character, but that character is something other than a little t. Okay, it could be any character in my machine's character set except for a little t. Yes, question? Oh. See, you have to use both hands at once. If you use one hand first, then I get panicked. All right, so let's take a look at this example. We're looking for, so what does the first caret mean here? Start, right? Beginning of line. Yeah, or beginning of string. All right, so the first caret means, let's look for lines that begin with. Now, what does square bracket caret t mean? Something that's not a little t, right? So so in square brackets, if I say caret t, that means I'm looking for a character which is not a little t. Let's just stop there, but let me look at my poem. Okay, so let me look for, instead of little t, because I don't have any, every line in the poem begins with a character that's not a little t. Let me look for a character that is not a capital H. All right, so here we're going to look for lines in the poem where the first character on the line is not a capital H. Make sense? Okay, we have a lot of lines in the poem where the first character on the line is not a capital H. Here we have a dash, and then we have a space, space, capital A, space, space, capital A, space. So we've got many lines in this poem where the first character is not a capital H. In fact, remember we had 3 lines where the first character was a capital H, and so this is all of the other lines. This is all of the lines where the first character is not a capital H. Okay, I lied slightly, because we do have some lines that don't contain any characters at all. And this pattern says, look for lines that begin with some character that is not a capital H. So if I have an empty line, a line that has no characters at all, that won't match. There has to be a character at least, and that character can't be a capital H. All right, now let's change this back to a little t. And this time I'm adding a star. And the star means to match any sequence of 0 or more of whatever the regular expression is in front of the star. So we're matching 0 or more of what? Non-t's, right. And in fact, we're going to do that all the way up to the end. So what does this say? This says, look for lines where between the beginning and the end, the only characters that exist are, if any characters exist, because star means 0 or more, if any characters exist, they can't be a little t. They can be anything other than a little t. So let's see if we've got any lines in this poem that don't contain a little t anywhere. And t is a pretty popular character in English, so not going to be too many of these. Okay, so we had the line of dashes, the underscore under the title. We also have the 3 empty lines. It's hard for me to highlight emptiness. All right, so I've got an empty line there, I've got an empty line there, and I've got an empty line. So those lines don't contain any little t's. And then I have 2 lines of letters and punctuation marks that don't contain any little t. All the other lines do contain at least one little t. So tail, water, neatly, little, gently. Okay, so there are a lot of little t's in most of the lines in that poem. Any question? Cool. All right. And then finally, what if I want to look for a line that contains an actual period character? The dot matches any one character. So if I want to look for a literal dot, a literal period character, I have to stick a backslash in front. Now, my poem, if I look at my poem, I see that Lewis Carroll was an excitable fellow here. Didn't use any periods in this poem. All we have here is a couple of exclamation marks as punctuation in this whole poem. So if I do a search for lines that contain a literal period, I'm actually not going to match anything. But let's do that, just to prove that I'm not going to get any matches. Okay, I have no lines in here that have a literal period in them. So now let me edit the poem and just arbitrarily change one of these exclamation marks to a period and run my command again, run my program again. And there we are. So now I did match the one line that does contain a literal period in it someplace. Okay. All right, so we've now looked at all of these so-called so-called basic regular expression characters. Virtually all systems that support regular expression matching provide this collection of regular expression characters. The caret for the beginning, the dollar for the end, dot for any one character, square brackets for some collection of characters, or if you have an initial caret inside the square brackets, it means a collection of characters that is other than what's in the brackets. One character that is other than the characters in the collection. And then we've got star to match a sequence of 0 or more, and backslash to turn off the special meaning of the next regular expression character. Any more questions about these things? Good God, how can this guy have talked for an hour about one slide? Okay. Yeah, regular expressions, I mean, it's very compact, it's very powerful, it's confusing. You just have to do a lot of experimentation with it to get it to make sense. Once it sinks in, you'll be really, really happy that you understand how this works. Let me show you an example, an extracurricular example here. You may remember that on a quiz, I asked you to define a tuple T just containing the value 777. Do you recall that question? And there's a way to do it. But how many ways are there to do this? Well, how many do you want? There's also T gets 777 comma with no spaces, and there's T space gets 777 comma close parenthesis, and there's T gets space open paren space 777 space comma parenthesis. All of these work, but there's no way in Canvas that I could match all of the possibilities. So I listed a bunch of possibilities that I thought you might type, and inevitably, 5 or 6 people type something that's not one of the guesses that I made. But if I had regular expressions available in Canvas, it would be easy, because I would be able to say lines that begin with some number of spaces followed by a T, followed by some number of spaces followed by an equal, followed by some number of spaces followed by an open paren, followed by some number of spaces followed by 777, followed by some number of spaces and a comma, and some number of spaces and a parenthesis, and some number of spaces up to the end. That regular expression matches all possible ways of typing the definition of a tuple named T containing one value 777. Doesn't matter where you type spaces, I've got a pattern that matches any conceivable combination. So Canvas sucks. But there are a lot of tools that provide regular expressions that make it possible for you to write very concise patterns like this that will match any kind of possible user input that's in a valid format. So it's really good stuff. Onward ho. So here are some additional regular expression special characters. The vertical bar symbol, which I don't seem to be able to highlight. Okay. The vertical bar symbol means or. That is, you will match if you match the expression on the left of the vertical bar or the expression on the right of the vertical bar. Let's see an example of this. All right, so here we're looking for lines in the poem that contain how with a capital H or Nile with a capital N. Let's give that one a try. Okay, so we're going to look for how with a capital H or Nile with a capital N. And there we are. So here are all of the lines that contain either how with a capital H or Nile with a capital N. Turns out there are 5. Good? I want to point something out about the vertical bar and also about the font in these PowerPoint slides. You might, now, okay, so in this font, it's not so bad. It looks like the little w and the capital N are right on either side of the vertical bar. But people sometimes get confused either by the font or by just not understanding how the vertical bar works and think, well, I just want to make it look nicer. And so I'll say how, and then I'll put spaces around the vertical bar. This is a valid regular expression that does not match what you're trying to match. It looks for lines that contain capital H, little o, w, space, or that contain space, capital N-I-L-E. In this particular case, it accidentally matches exactly the same 5 lines because every instance of how does have a space after it, and the only instance of Nile does have a space in front of it. All right. So it's an accident, and you think, okay, I did the right thing because I got what I expected. Well, you got the right thing because you were lucky. If this were a longer poem, and we had people in here named Howard, then without the space here, I would match Howard, but with the space, I'm not going to match Howard. All right?
Or even if we write them the other way around, Nile or how.
Oh, yes. It certainly will work to do these in the opposite order. Nile or how is equivalent to how or Nile.
But the font part with the space.
Right. In fact, this time you'll get only one match. I'm looking for Nile space or space how, and I know about the poem a bit, so I know that I only get one line that happens to have a space in front of the how. Yeah.
How does Python know that the bar has to match the whole word and not just E or capital H?
Excellent question. Why? Yes. Why does the vertical bar? Yeah. Why does the vertical bar not look for either little e or capital H? Okay. Why doesn't it look for a capital N-I-L followed by either an E or an H, followed by O-W? I guess the answer is because it has lower precedence than just regular characters, than a regular character sequence does. If you wanted to look for capital N-I-L followed by either an E or an H, followed by O-W, you can use parentheses like so. You can put parentheses in here. And that says to look for capital N, little I-L, immediately followed by either a little e or a capital H, immediately followed by little O-W. Okay, so excellent question, and the answer is the vertical bar has very low precedence relative to just ordinary characters. Okay, so I told you now about the parentheses, and it turns out that not only can you use parentheses to contain a regular expression, but the parentheses also create what's called a group, which you can then match again by using backslash followed by the group number. Now, when you use parentheses to create groups in your regular expression, the groups are simply numbered from group 1, group 2, group 3, group 4, working from left to right. Okay? So, in this example, what I'm saying is, I want to look in my, I want to check in my string whether there is a lowercase vowel that is either an A, E, I, O, or U. I'm going to create that as a group and then test whether that very same character, that very same match, happens again. So \1 here does not match the pattern A, E, I, O, U. It matches the match of A or E or I or O or U. So what I'm saying is, look for lines that contain a pair of identical lowercase vowels. See if we have any of those. So Pat is R of, okay, now I'm creating a group. And within the group, I'm going to have square bracket A, E, I, O, or U. So one character, which is a lowercase vowel. But then I also want to match another occurrence of that exact same character. That's what the \1 is about. And it turns out in the poem that I only have one occurrence of a pair of identical lowercase vowels. Which makes sense. I mean, pairs of identical lowercase vowels in English are not that common. Let me add a couple more just for gags. Whoops. Okay, now I have extended the stupid poem and made it even more stupid. Okay, so now I have cheerfully matching, and I have aardvark matching, and I have food matching. Okay, so I'm looking for a lowercase vowel immediately followed by exactly the same lowercase vowel by using a group and then the match of that group \1. Yeah. Correct. \1 matches the first group. Let's take a look at an example where I have multiple groups. Okay, yeah, we'll skip ahead. So in this pattern, I'm matching any character. That's going to be a group. That's going to be followed by any other character. That's a second group. That's group number 2. And then I'm matching any other character, and that's group number 3. Now, * means any amount of characters, right? So * matches either nothing, or a character, or 2 characters, or 3 characters, or however many characters. And it doesn't matter what those characters are. Now, notice following the * that I am referencing the groups, but in a different order from how they matched. I want to look for a match of the third character followed by a match of the first character and then the second character. Let's see if we have any lines that match that. Whoopsie. What happened? No. I closed my program. I have to reopen it. I don't know why my trout stream maps popped up there. No, here's my program. Okay, so right. I just need to type in this pattern. So my pattern is going to be look for a character and label that as group number 1. Immediately followed by another character, and that will be labeled as group number 2. Immediately followed by another character, labeled as group number 3. Then look for any number of any characters. And following that any number of any characters, I want to look for group number 3 followed by group number 1 and group number 2. All right, let's see if we can get any matches from there. All right, so we got some matches. Let's see if we can figure out where these matches are. Now, the first line is actually pretty easy. Here are characters 1, 2, 3, and they're immediately followed by the same characters 3, 1, 2. They're all dashes. For the next line, it's the same thing. I've got space, 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 1, 2, 3, immediately followed by space, 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 3, 1, 2. All right, these last lines are trickier. The last, okay, actually those aren't matches because the pattern matches 3 characters and 2 spaces is only 2 characters. I'm looking for 3 characters 1, 2, and 3, later followed by those same characters, but in the order 3, 1, 2. Okay, this one, the first line, other than these dashes and these multiple spaces, is tricky. It's right here. E space L. All right, E is character 1, space is character 2, L is character 3. That's followed later by 3, 1, 2, L-E space. Okay. And what about this next one here? It's actually right here. HIS is 1, 2, 3, and SHI is 3, 1, 2. And here we have N space E followed by EN space. Okay, so this is stupid, right? Good heavens. Why does this matter? Well, let's suppose that you're looking at some kind of massive text report, and each line of this text report has like people's names and dollar amounts in it, and you want to find all of the lines that have first name, last name, dollar amount. And then later on the same line, dollar amount, first name, last name, matching. Maybe that, I don't know, maybe that's some indication of some kind of accounting issue. And so you can use this trick involving groups and then changing the orders of groups and looking for the same groups on the same line. Or a more obvious example would be, what if you needed to find lines in a document that contained a first name followed by a last name, and then a bunch of characters, and then the last name followed by a comma followed by the first name. Again, you can set up groups to match the first and last name, and then later refer to those groups to match the same last name followed by a comma followed by a first name. Some of these things you will not use very often, but when you need them, they're fantastically wonderful to have. Has anybody ever heard of DBase? Not a clue. Well, good heavens. I mean, in the mid to late 1980s, DBase was one of the most popular development environments on IBM PC clones for managing data, DBase for database. And it stored data in tables, and it also had a language for allowing you to extract information from the tables and analyze the information. And it had a competitor called Foxbase, which was compatible with DBase mostly, but not quite, and a lot faster than DBase. And so, DBase was in the lead, and Foxbase was a close competitor. But the function syntax for Foxbase was subtly different from the function syntax for DBase. And I had a client who had this massive DBase application that worked, but that was slow, and they wanted to change to Foxbase. And I was able, in an afternoon, to write a program using regular expressions to convert their entire many dozens of files of DBase code into equivalent working Foxbase code. And if I tried to do that manually with an editor, it would have taken me weeks and weeks, and I would have made all kinds of stupid typing mistakes, and it would have taken probably months to get the whole thing debugged and working. But knowing regular expressions well, I was able to do it, literally in about 2 days. Like a day to create the regular expressions and another day to run it and test it all out, and it was done. So, yes. So it's cool. It's amazing. It's wonderful. Any questions? Okay. Now, in this example here, what we're looking for is any 4 characters followed by any number of characters followed by the same, I'm sorry, that's not 4 characters, that's 3 characters, followed by the same 3 characters later. Let's do that one. I made a lot of money doing stuff in languages and systems that nobody's ever heard of nowadays. All right, so let me look for 3 characters, followed by anything, followed by those same 3 characters in the same order again. And here we are. So these are fairly easy. I have space th, followed later by space th, and then I have es space followed by es space. And I've got one that I made up, so I don't already know where the answer is. Here we go. ND space and ND space. Okay, so that's the basic and extended regular expression characters. I also want to point out, as I sort of briefly mentioned before, that one of the things that regular expressions are really useful for in Python programs is if you're trying to read input from a user, or you're trying to read input from an unformatted file, and you want to confirm that the format of what the user types or the format of what you're reading from the file is accurate. It's correctly structured. Well, you can typically write a regular expression that will match that valid syntax, and obviously I did an example of that involving this tuple that I then erased. That was stupid of me. But here's an example. Suppose that you ask the user to enter an integer. Well, you can define a pattern for what an integer looks like. It has to start with a digit between 1 and 9. It could start with a 0. Followed by 0 or more additional 0 to 9s. All right, so if you read an input from the user and that input matches that pattern, that means the user typed a valid integer value. Otherwise, they didn't. Similarly, if you're trying to match a Python identifier, a variable name, a function name, a class name, we know what the rules are for that, too. We know that the first character has to be a letter or an underscore, and additional characters, if any, have to be letters, underscores, or decimal digits. If you want to match a Boolean, well, there's only 2 possibilities for a Boolean in Python. Either the word true or the word false, and on and on. Questions? All right. Well, evidently, we will look at reading and writing formatted files on Thursday. This won't take very long, really. So I'll see you then.
Professor, our next project